Welcome to Brain Vision.
So there are two blocks connected to each other over a pulley. We have M2 and M1, and they're connected over a pulley, something like this, just a rough sketch. This is at a height h. So we can write, first of all, we're trying to find the speed this block is at once M1 hits the ground. So we can write a big equation with all the energies. So the change in kinetic energy for M1, and then we need the change in kinetic energy for M2, and then the change in gravitational potential for 1, and the change in gravitational potential for 2, and that's all 0. We have no external work. So the change in kinetic energy, that's going to be 1/2 m1 times vf squared minus the initial velocity squared. Then we can write the same thing for m2. Vf, I guess I should write vf1 and v0, 1, and this is for 2, minus v initial for 2 squared. And then add in, let me move this down, add in the potentials. The potential for 1 is going to be m1 times g times the change in height, so y final minus y initial. And then m2 times g times y final for 2 minus y initial for 2. That's all equal to 0. Okay, so let's go back to the side. We have 1/2 m1. The final velocity for m1 we don't know. The initial velocity is 0. They both start at rest. So this is just the final squared. The same is true for m2. It starts at rest, ends at an unknown final velocity, which is what we're looking for, this number. And then we can add m1 times g times the final height of m1 is 0. I'm calling this 0, right? And then its initial height is h. And then m2 times g times the final height of h and initial height of 0. Now, the speed of both blocks is always going to be the same. They're connected, right? So vf1 squared and vf2 squared are the same thing. So I can just call that vf squared. And now, well, this is going to be minus m1gh, and then plus m2gh. So now we want to solve for velocity final, so I can factor that out. I can also factor out a 1/2. I get m1 plus m2. And then this is plus g times h times m2 minus m1 equals 0. Now I'll bring everything over that I can to the other side of the equation. So vf squared, I'll keep this over here for a second. So we bring this term over, we get gh times m1 minus m2, they switch, and then times 2 for this 1/2. And then I can divide by m1 plus m2, and then take the square root. So this is 2gh times m1 minus m2 over m1 plus m2, and then take the square root of the whole thing to get the final velocity. That's the speed that the block is at. That's the speed that both blocks are at once m1 hits the floor. And then to figure out how high M2 goes, well, it's going at some velocity, which we just solved for, and then it's not just going to stop immediately, it'll keep going up in the air. So I'll write a new equation for just M2. This is starting at right when M1 hits the floor. So delta K plus delta U. Now, our change in kinetic energy is going to be 1/2 times M2 times our V final. I'll just say V squared so we don't get confused with this one. Minus V initial squared, which is actually the V final from part 1. So this is going to be a little confusing notation, but the V initial is actually V sub F. And then this is plus M2 times G times, say, maximum height, so H max, minus, I guess, H initial. So we have 1/2 times M2. Well, once it reaches its maximum height, its velocity is going to be 0. And remember I said its initial velocity is actually Vf, which is this Vf that we found. It's going to be that whole thing. And this equals, let's see, minus M2G times H max, and H0 is just H. So this is going to be, well, this minus ends up canceling with that because we get a minus in the front, and then the M2's cancel, so we're left with 1/2 Vf squared equals G times H max minus H. So this is Vf squared over 2G equals H max minus H, and we're looking for H max, which is going to be Vf squared over 2G plus H.